get to Italy can be determined using some econometric models that we have there. So driving the car, looking through the window is good for the next meter. And it probably won't happen anything if you drive 1 meter. If you drive 1 kilometer, that's another story. You need something better than the rear mirror. So for short-term international movement prediction is okay, very short-term. If you go beyond, you need to ask him what's going on. And that's one thing. The other one about the tours, my wife and I have worked with optimization of time windows tours in which you go to a supermarket and if you sell, we have worked for the Coca-Cola in Chile and Brazil, and Coca-Cola has thousands of clients in a city. We were planning, by the way, I don't know how is that gonna work. We designed the system for Coca-Cola in Brazil for the World Cup, Football World Cup in 2014. We will see how that works. But they have thousands of clients, and you have to deliver Coca-Cola to these different thousands of clients. And they have time windows. They say you can bring the Coca-Cola from 8 a.m. to 10 a.m. The other one says from 1 p.m. to 3 p.m. The other one says the whole day. The other one to Thursday and Tuesday. And the other one says only at night. You have to plan for all that. The optimization problem to do that is huge. It is virtually made of millions of integer variables, which is a very complicated optimization problem. If some conditions change, the whole model doesn't work anymore. So you have to redo it and run it again. And that's not nice, because you know the truck is with all the Coca-Cola, and he starts and he says that the first client says, okay, no, I don't want Coke today because yesterday I didn't sell anything, so my space is taken. So where do I go now? So most of the truck drivers don't actually look at the roster that you give them to follow, because they know that they're going to be wrong at some point. So there should be a way to incorporate the dens of the system in those models, decreasing the quality of the solution in terms of the optimization, but increasing the usability of the model, assuming that stochastically some things could happen. Some clients will not want the Coke, some others will need more, and such and such. And that can be done incorporating a mixture or a hybrid system with agents and optimization. And that's one of the areas that people are working today. The data. The data is an issue that needs the complement of many different professionals. The old way of getting data was to go to the streets and stop people and ask a survey. What do you want? What do you do? Where? How? And now people are fed up with surveys. In places like Germany, the constitution protects you to answer any type of survey. To make a census of people in Germany is a huge endeavor, because nobody wants to answer that. So how do you count people if people don't? So we have to deal a different path, in my opinion. Those people, let me take this, have the answer. They have every single movement you do in your day. They know every single person you call at every single time of the day. And they are not very shy with sharing that information. There's no surprise that you're having lunch and you receive a call from a bank that you've never been at and says, Mr. Comey, we are the bank of blah blah blah, and we would like you to become one of our clients. We have seen that you have interest in the academia, and we are prepared to have customers in academia. And you say, how do you know who I am and what I do? Well, that's not important, Mr. Comey. Please come to us. Because they sell that data. So we can do many things. We can make arrangements with companies to get data, what is called statistically unnominated. So I don't want to know the name of the person, but I want to buy terabytes and gigabytes of connections between people. I want to buy that because I need it for my study. And also, free platforms like Waze, you know Waze for the car movements? Waze have the movements of cars. For instance, in Santiago de Chile, there are about 20 to 30,000 active users of Waze every single time. 30,000 people in a network is a fairly large number of data providers. So you can also make deals with them and give them something in return. Say, allow me to use your database and I will provide you with models that can be of service to you. Business models, clustering models, I don't know, business economic sort of tools. So that's a better way to go and stop you in the car or walking and ask you to tell me your income, what you do, etc. They can pretty much get your income from many places, and they do. Or you can infer your income according to the plan you have in your phone, the number of calls you do, to whom you do these calls, stuff like that. What are the stores you buy? Those
what type of goods you buy?
Exactly, and so that's, I think, the modern way to get data for this type of usage.
Which in a sense is becoming more available at a lower cost.
Yes.
According to what you are saying.
That's what I sense. They have much more than they actually declared they
We have to think of new ways of getting the data.
Exactly. Actually, Laszlo Barabasi, this professor at Harvard, made an agreement with cell phone companies in the US to get every single call from people in Boston and draw a network of connections between people.
Another guy that's using this approach you're describing is Michel Gerler. I'm not sure in Lausanne he has a big contract with Nokia. He's applying this concept we are describing for route choice.
Mm-hmm.
He's trying to model how people...
Yes.
But before I ask a question, there is Andrea Papola.
Yeah. You make me very curious, but you stopped at the best time, best moment. Could you give us some more ideas of how this agent-based approach can face and reproduce all the complexity that you remember as belong to the freight world?
Yeah. There are a few things that agents can do. They have rules. You have to decide simple rules for an agent. An agent either buys a stock in a stock market when something happens or does not buy the stock. Stuff like that. Very simple. But it's actually how investors buy stocks. You know, they have information. If something triggers, they buy. If that thing doesn't trigger, they don't buy. So agents and real people, in that sense, sort of work similar. When you decide in a transportation network what link you're going to follow with your car, we don't actually know the cost of every single arc in the network, which is the assumption of ceteris paribus that wardrobe uses for that. So forget about it and do it as you would do. You go and you look to your right and see a line of cars, so you change your mind.
Yeah.
So that's your rule as an agent. If the street is complete, do not go in there. If the street is at least half empty, go there. That's your rule. That's the first thing. To analyze the real system and translate that into simple rules. Once you have two simple rules, you have to have a way of interaction between agents. An agent is the street, an agent is the driver, an agent is the traffic light. All of them convey information. You can have an agent like yourself that has a memory of small size. People can have in their minds a very small amount of information to make the decisions. So your agents may know previous information of shortest routes. When I come from my home to this campus, there are only 4 routes that are good for me. And these 4 routes are good. These 2 are good in weekdays, these 2 are good in weekends. If it's raining, only number 3 is good. So those type of information can be
sort of heuristics that you develop through experience.
yes, in your mind, and they're very narrow. You don't have like 1,000 strategies like in
That's true. That is exactly
yeah.
what you usually do.
In games, in game theory, you may have millions of strategies. Well, that doesn't happen with people. You don't have million anything in your mind. You have a few of them. So, there's rules, there are a way to communicate and convey information, and there are constraints. What are the constraints? For instance, time windows, or rush hour, or so the system now, more than the agents, the systems has conditions. You can put that conditions in there. Are we done with that? Yeah. And so in a freight system, you could have actually, if you want.
That's okay. We can go.
Carabinieri will come.
No, not yet.
Not yet. You can have an agent that decides according to a logic model if you want. So it has the logic formula with utilities or costs and say, okay, I will choose this or that according to a logic model. That's a simple rule that can be done. So you can follow a path from national to regional to urban, following agents with transportation functions embedded in the decision rules, so far as are simple rules. If the rules are not simple, you become very quickly an analytical model again, which cannot be calibrated, and it takes days of computer to... Because the good thing about a system, a hybrid system with analytical models and agents, is that you can run that several times with different starting points. And let's think about demand modeling or demand forecasting. If you're trying to predict demand for a seaport, the investor would like to know not only the amount of freight that he or she will receive, they would like to have some sort of distribution to say, with 5% probability, the number of cargo that your port will handle will be this. With 40% probability, you'll receive this, and with 15% whatever. So the investor has the information to decide, well, I'm a risk taker, I'm going to go this way. In order to have this distribution, you have to run your model several times with several starting points.
You have to simulate the different ceteris paribus for each
Exactly.
situation.
To allow the system to dance, And with that dancing, patterns will emerge. And those patterns have different probabilities, so you can draw a map of probabilities and scenarios. A scenario with probability for an investor is much better than a number.
Rodrigo, this is very interesting what you're saying. I think it's also very useful in order to simulate what Antonio was saying before, in the sense that, many times what you want to discover is how the system reacts to a change in policies. But this was linked to an idea that came to my mind while you were speaking. Basically, by using different starting points, you try to simulate different system equilibria, system solutions, in a sense. But the thing that is interesting to me, and I also look at this from a maybe policy perspective, is basically, if I'm not an expert on this, but the main idea you are giving us is the following. You have agents that have some given heuristics, okay? And they, according to the use of these heuristics, you are able to simulate the interaction in the system. But two things. Could it be that the heuristics are heterogeneous among agents? First question, how do you take this into account? And second issue, can these simple rules, given that they have to be simple to be working, to give the sort of information you are describing, couldn't there be a problem of endogeneity, in the sense that through interaction, you were mentioning learning mechanisms before. I have a simple rule and I start to interact. I see that through experience, the rule I'm applying, given the results I'm receiving, it doesn't look optimal to me, in the sense that I thought that this rule is good on weekends if it's raining, but then I start interacting and I see, by, as you say, driving through, I see that route over there could be better, in the sense experience influences the simple rule I am using. How do you model this? And could it?
This is calibration, I think.
Well, yeah.
What I'm saying is, the impression I've had from, at least from the description, and it's surely due to my lack of understanding, is that the decision rule has to be simple and given, basically.
Yes.
What I'm saying, could it be that interaction gives me information that makes me change my mind? If I see a route which is 50% empty, don't take it. But given the experience, I should take it because the idea I have is this. I see a route which is very full, okay? So I shouldn't take it. But sometimes this really happens to me. The route is full, but it's just because of something very small happening. It's just around the corner. You turn the corner and the route is totally empty again. Right. So how do you...
Yeah, there are two things. These models are halfway between deterministics and stochastic. They're actually chaotic. That means that they depend on the starting conditions. You can have many different agents with different rules. You can have, for instance, an agent which is a man and an agent which is a woman, and they could have different rules within the different system. You can have an agent which is a truck driver and a passenger driver, and they have different rules. So that there's no problem in modeling that. You can have many different type of agents.
So heterogeneity in the decision rules is not a problem?
It's not a problem at all, yes. You have many different agents interacting to each other with different rules. The thing about what happens when you decide a priori what are the rules of the agents is that what you're trying to achieve is to see what goes on with the system when you assume a certain set of rules. If those rules change, the system, the patterns that emerge from the system may or may not change. So you can play with that. You can say, people who take the road with up to 75% of the road full of cars, if they act like that, we will have eventually an equilibrium. But if it's more than 75, the system will never find equilibrium, because everybody will be not moving, will be trying to, oh, this road, oh no, this one is too heavy, I'll take this other one, they will never go home, okay? So, one thing that traditional transportation models do not have is conditions for not equilibrium. They will always looking for equilibrium, Nash equilibrium, Wardrop equilibrium, but what are the conditions of the agents that make possible the equilibrium? The equilibrium is not a characteristic of the network. It's a characteristic of the interaction between different agents and the network. What conditions of the network and what conditions of the action of the agent's rule preclude equilibrium? And there are very nice examples in NetLogo, which is free to download, is the racial accommodation in a city. You start with a city, let's assume Rome, that you assume that people have a simple rule. I'm comfortable in my neighborhood if the race of my neighbors, if 50% of them are of my same race. If they have a different race, I'm not comfortable, then I move to a place where at least 50% are my same, are Latino, for instance. Yeah. If they're not Latino, I don't feel comfortable, so I move to another place. It is interesting, because if you have that, and if you have a people who says, I allow 15%, 25%, 35%, there's equilibrium in the system. You run the system with millions of people and they start moving, and then they form spatial patterns in which that is set. As long as you increase the degree of racism to, let's say, 75% or 70%, that means I feel comfortable if 70% of my neighbors are like me. That system does not have an equilibrium, and people will continue moving around, keep moving, because no equilibrium is. So you can set what amount of racism is stable in a city. You see?
How racist you can be.
Yeah.
What's the maximum level of racism
Yeah.
I can accept in order to get a stable solution?
Exactly. And so you can do pretty much that with transportation as well. You can try to see, well, how much I'm willing to wait
between
routes to get a good equilibrium. Or, in other words, you can make a list of all the things that could happen that preclude equilibrium, which is also an interesting thing to do for policy. If this and this and this and this happens, transportation will never reach equilibrium in the network, which you're not able to do with the traditional equilibrium problems, which are only obsessed with equilibrium.
Basically, could we say that these type of models are more interested in short run, or at least in the transient, rather than in the long run? Because the concept of equilibrium is always a medium to...
Yeah, but you can
we do not look at what's happening in the meanwhile.
But you can still do that, and that was one of the last questions that I didn't answer probably to Antonio about the land use, for instance. You can create a long-run model in which you have different agents. On one side you have the people, the network, and the land use. They will buy houses and build, distribution centers in different types of the parts of the city according to the law that allows you to do that. And you have the system to evolve 20 years. And the system evolves as well as the transportation, as well as the people, increasing number of people, increasing number of immigrants, increasing number of cars, and you allow the system to dance in different scenarios, starting with different starting points. And you can say, in 20 years down the road, there's a certain probability that this part of Rome will be totally congested, this other one will be a commercial area, this will be a residential area, will be short of water, short of electricity, short of whatever, if these scenarios evolve in the way so you can still do long-run analysis as scenarios with probabilities.
This should be, at least for intelligent policymakers, very interesting tools.
It should be.
I mean, interesting policymakers, because usually policymakers just like one single number with 100% certainty.
Yeah,
that is the average.
And we know that that is not true.
Yeah. No?
Yeah.
Because in order to understand this, I find it very interesting.
Yeah, thank you.
Could you suggest us some papers?
Yeah.
To go deeper in the...
If you email me, I of course did not bring my cards, but you can write her and she will give me the... I think I do have both of your cards when we met in Rome a few years back.
If you want another one. Okay.
Yeah.
So I think we can close the presentation here. I would like to thank Rodrigo again.
Thank you. Thank you very much.
We are set for lunch now.